Chemistry, Unit 3, Electrolysis 101. So in this section, we will talk about the basics of electrolysis, and we'll do so by transforming a galvanic cell into an electrolytic cell. So from the study design, we're required to compare an electrolytic cell with a galvanic cell with reference to the energy transformation involved, as well as the basic structures for both chemical cells. Okay? So let's look at our good old friend galvanic cell. So we say that galvanic cells utilize a spontaneous chemical reaction and obtain energy from that spontaneous chemical reaction. So the reactants will spontaneously react if they are put together, if they are in direct contact with each other. So we need to separate them into two half cells. Okay? And then electrons travels from the half cell where oxidation happens. So oxidation is losing electrons, and the electrons is lost to the external cell. So where oxidation happens is defined at the anode. The electrons come from anode all the way back to through the external cell back to the cathode where reduction happens. So the reactants that you put in the other half cell is going through a reduction half reaction by receiving electrons from the other half cell through the external circuit. Okay? So red cat. Then because they are separated, we need a salt bridge to connect both cells. And in this way, we will then have a complete circuit. We have an external circuit, and it is run by electrons carrying the negative charges through the external circuit to the cathode. Yeah? And then the negative charges or carried by ions, actually in this case, will then travel through the inner circuit, that is the salt bridge, back to anode. We have a complete circuit of negative charges for a galvanic cell when it's actually working. So overall, a galvanic cell produces electricity. It converts chemical energy from a spontaneous redox reaction into electrical power. So the light lights up. Here's another diagram of a galvanic cell. So we see this is anode, that's the cathode. Everything's the same, just instead of a light bulb, we put a voltmeter to detect the voltage. Now, when your battery runs out, let's think about when your phone runs out of battery. What's the first thing you're going to do? You have to recharge it. So in order to recharge it, you will intuitively connect it to a power source. Yeah? So when we want to recharge a battery, we must connect the battery to a power source. How do we connect it? We connect the negative end of the power source to the negative end of the battery, and the positive to the positive end of the battery. Okay? So when we recharge it, the power source has a lot of electrons. So electrons are injected into, straight away, the negative end of the battery. So this end is out. So electrons still come from the negative end, but now it's the power source. So electron comes here. And because of this very powerful power source, you'd notice that the flow of electrons through the external circuit is completely the opposite. Now electrons flow from here in this direction into the negative end of the cell. And because electrons are injected here, then this oxidation reaction, you have injected electrons here, it is forced to go backward. And so there used to be an oxidation here at the negative end of the cell. Now, because the injection of electrons, it's forced to go reverse, and therefore it becomes a reduction reaction. So anode becomes cathode. Okay? On the other half, what happens is that the electrons here are attracted by the positive end of the power source. Okay? So this reduction reaction also go reverse. So copper now is giving out electrons. And where does the electron go? Electrons goes away from the positive end of the battery and back into the power source. Okay, so electrons still flies in the reverse reaction in the external circuit. And because this becomes an oxidation reaction, that becomes an anode. So you notice that when your battery is being recharged, the cathode and anode will swap place because of the reactions being reversed. Okay? And since now the reactions are reversed, you notice that our new reactants, zinc 2 and copper, according to chemical series, they cannot react spontaneously. Right? Since they can't react spontaneously, it doesn't matter if they're put together. So we don't need two half cells anyway. Okay? So when we're recharging a battery, when it's an electrolytic cell, because the reactants will not react spontaneously, they are forced to reacting that way by the power source. Okay? So we don't really need two half cells. We can actually connect them to become in the same cell. And because they're no longer half cells, we can remove the salt bridge as well. So now the galvanic cell is transformed into an electrolytic cell, where the flow of electrons is in reverse compared to a galvanic cell, and also cathode anodes are in reverse. There are no more two half cells, they're just one cell. And you must connect to a power source to be able to do this transformation. So an electrolytic cell turns the electrical energy back into chemical energy. Okay? So for all the batteries in your phone and in your laptop, they are all secondary cells. Secondary cells means the battery can be recharged. So it is literally a battery with two phases. One phase is that when it acts as a galvanic cell. So that's when it's discharging. During discharging, it acts as a galvanic cell, and we utilize a chemical reaction to obtain electricity. So electrons come from the oxidation half, and by definition, that is the negative end of the battery. And also that's the anode as well. And the positive end will then receive electrons from the external circuit and become the cathode. And once the battery runs out, we need to connect it to a power source, and then this battery is turned into an electrolytic cell. So a power source is needed to supply electrical energy, and we are shoving the electrons back into the negative end of the battery. Okay, so because electrons are supplied to this end, this is where cathode is, and this is where a reduction reaction takes place. And on the other hand, the positive end of the battery is where oxidation happens, and therefore that becomes the anode.